In an era of incredible military and technological innovations, a Soviet engineer dreamed of bringing light to desolate regions of Russia where nighttime prevails. Vladimir Syromyatnikov conceived the idea of creating a colossal space mirror capable of reflecting solar light back to Earth. This feat would light entire cities and boost agricultural productivity in Soviet regions where daylight was scarce during the winters. The Znamya satellite faced a lot of opposition from the government and the Soviet space program. Still, Vladimir went public and got the required funds. His dream project was now a reality. The plan was to launch several space mirrors, each larger than the last, until one became permanent. After years of development, Znamya II was launched in October of 1992, and for a brief moment in time, it lit a small portion of the Earth. The ambitious Russian project seemed taken straight out of a futuristic movie. A visionary Soviet engineer. Vladimir Syromyatnikov was born in Russia on January 7, 1933. From an early age, he was fascinated with the world of engineering and technology. Young Vladimir grew up amidst turbulent times. Joseph Stalin's regime was known for its violent tactics, an iron fist against anyone who opposed him, and continued military and political purges. Stalin's obsession with militarizing the Soviet Union and making it the most efficient industrial and economic bloc in the world had a tremendous toll on its population. Millions of workers were exploited, and Stalin went on to eliminate weekends to bolster productivity. It was also a productive time for ambitious engineers and scientists, as the USSR desperately sought an advantage in technological innovations during the arms and space races with the United States and its allies. Vladimir eventually graduated from the Bauman Moscow High Technical University and the School of Mechanics at the Moscow State University with a degree in engineering. In 1956, he joined the team of engineers at the Korolev Rocket and Space Corporation Energia, who were tirelessly working on the design of the Vostok, the first piloted spacecraft in the history of mankind. After working for over a decade in the space engineering industry, Vladimir eventually became the department head of Energia in the late 1970s. He helped design spacecraft, onboard manipulators, and docking systems. Vladimir also developed the Androgynous Peripheral Attach System, or APAS, which allowed two spacecraft to be coupled either temporarily or semi-permanently. This effective docking mechanism would be used in 1975 to link up the Soviet and American space capsules that were part of the joint Apollo-Soyuz program, the first crewed international space mission. An upgraded version would also be used in the 1990s to dock the shuttle Atlantis with the Mir space station. It was during these years that Vladimir Syromyatnikov became fascinated with the idea of solar sails. A giant space mirror. In 1988, the United States proposed to commemorate the 500th anniversary of Christopher Columbus's arrival to America with a solar sailboat race between the Moon and Earth. Although the US soon discarded the project because of economic reasons, the Soviet Union continued its development through the Space Regatta Consortium, or SRC. This partnership was formed by Energia, Vladimir Syromyatnikov, and other Soviet intellectuals. Its objective was to test solar sail technology for future projects. According to author Louis de Guyon from Space Legal Issues, solar sails were, quote, a method of spacecraft propulsion using radiation pressure exerted by sunlight on large mirrors. Vladimir's idea was to design a solar sail system that could use the sun's power to propel a spacecraft through space and reflect sunlight back to Earth during nighttime. Columbia University professor Jonathan Crary would later write in his book 24/7, quote, the scheme called for a chain of many satellites to be placed in sun-synchronized orbits at an altitude of 1,700 kilometers, each one equipped with fold-out parabolic reflectors of paper-thin material. Once fully extended to 200 meters in diameter, each mirror satellite would have the capacity to illuminate a 10-square-mile area on Earth with a brightness nearly 100 times greater than moonlight. Although ingenious, the idea was not novel. German physicist Hermann Oberth and engineer Arnold Ericka had already developed the concept of a space reflector. This giant mirror would reflect sunlight on small parts of the Earth to provide nighttime illumination. However, Oberth's proposal involved developing the mirror as a solar weapon. The intention was for the system to incinerate specific areas or boil entire lakes and rivers. But the project was quickly forgotten during World War II. When Vladimir Syromyatnikov first presented the idea to the Soviet space program and the Soviet Union's top brass, he was not taken seriously. The proposal seemed too outlandish, and there were more pressing matters. It was 1988, and the once powerful Soviet Union could not afford to waste more money or funds on projects that would not have a direct and immediate economic benefit. One such concern involved finding a way to increase productivity in agricultural processes in northern regions with long days during summers and extremely short days during winters. To convince his comrades and attract national interest, Vladimir started marketing his solar sail project as a natural way to increase daylight extension. The results would then augment workers' productivity in farmlands. In an interview with the Moscow Times, Vladimir said, quote, we are pioneers in the field. If the experiment goes according to plan, we propose to send dozens more craft into space in the future on a permanent basis. The project attracted so much attention from potential backers that the engineer had to adjust his initial plans. Instead of using the solar sails to power spacecraft, he would now focus on developing the space mirror to light dark zones through the entire planet. Apart from improving overall workers' productivity in northern Russia, Vladimir pointed out that the project would also reduce energy costs in electric lighting and help rescue teams during natural disasters involving hurricanes or tremors. With all this newfound international attention, the Space Regatta Consortium was finally able to put together enough funds to move ahead with the development of the space mirror. In describing the engineer's ambitious plans, Jonathan Crary would write, quote, "But the company subsequently expanded its plans to include the possibility of supplying nighttime lighting for entire metropolitan areas. Reasoning that it could reduce energy costs for electric lighting, the company's slogan pitched its services as daylight all night long." Vladimir would later tell the Moscow Times, quote, "No more electricity bills, no more long dark winters. This is a serious breakthrough for technology." He named the future satellite the Znamya. Russian Eternal Light. Vladimir Syromyatnikov and his team first developed the Znamya, or banner, as a ground test model. The first Znamya was never sent to space, but it helped perfect the Znamya II, a 65-foot wide space mirror. Vladimir's plans were to first launch the Znamya II, followed by the 82-foot Znamya 2.5, then the 230-foot Znamya III, and finally a permanent 656-foot mirror installation. A 1993 New York Times article titled "Russians to Test Space Mirror as Giant Nightlight for Earth" detailed the space mirror plans. Quote, "Initial operational systems, using reflectors 650 feet in diameter, would have 24 to 36 mirrors in northern inclination orbits, either 620 miles or 3,700 miles above Earth. A reflector could light a spot by itself, or several could be focused on the same area for continuous illumination or greater brightness, scientists say, producing the light of up to 50 full moons. These mirrors, which would pivot as they passed overhead to keep their light on the same spot, could illuminate surface areas 35 miles to 55 miles across." The Znamya II was launched aboard a Progress M15 spacecraft from the Baikonur Cosmodrome on October 27, 1992. After passing through the Mir space station, the Progress spacecraft deployed the mirror next to the space station and produced a 5-kilometer wide beam of light, seen from southern France to western Russia. The bright spot traveled at an estimated speed of 8 kilometers per second, and although its luminosity was equivalent with that of a full moon, it was only partially seen on land because of excessive cloud cover above Europe. The success of Znamya II paved the way for Znamya 2.5, which was expected to light up to 7 kilometers of land with a luminosity equal to 10 full moons. But its main objective was to keep the spotlight at a fixed position for several minutes at a time. Nikolai N. Sevastianov, a ranking project engineer on Znamya, told the New York Times, quote, "The reflector was a big success because it proved the concept was right. Now we must seek support to build one of bigger size." Znamya 2.5 was launched on February 5, 1999, but as the sail was unfurled, the mirror caught on an antenna from the space station and ripped. Mission Control tried to free the space mirror, but the Znamya deorbited and burned up. Vladimir fought for the ambitious Znamya III, but the project was abandoned. The government decided that spending on the costly research program was pointless. There was also extreme opposition from environmentalists and scientists who claimed that space mirrors would have detrimental physiological consequences for animals and humans. The engineer still hoped to one day be able to light up to 6 Russian cities with the space mirror. He kept working on the project until he passed away in 2006. Vladimir's intelligence and determination not only earned the respect of Russian space engineers, but also of Americans with whom he worked 2 decades earlier. And since the Russian word for cheese is syr, Syromyatnikov is still fondly remembered as the Big Cheese.